we're looking at a device which can measure a pressure inside a container. So basically we have a container, and just a second. Yeah, this is the container. Say this is at a pressure of Pg, okay, pressure of the gas. This is a tank or a container. This is your opening. Connected to it is your manometer. That's it. The simple setup is your manometer. Okay. So it is exposed to the atmosphere. So you have some pressure over here. And this is, I can call it as level 1 and level 2. This height, we can take it as h. And that's that. Okay. So the agenda here is, the purpose is to measure the pressure of a gas in a tank or a container. So how are we doing it? We have one end a U tube. So this is your U tube. U-shaped tube containing a liquid is open to the atmosphere. This liquid's density we know. Okay, so whatever this liquid is, density is known with known density. Known density. So with all this set of information and us able to measure H, we'll be able to figure out the pressure in the container. Okay. The other end is connected to a system of unknown pressure of Pg working. So what is the funda over here? Simple. As point A, so over here, and B are at the same horizontal level, what happens? The pressure has to be same here, because they are at the same level. The pressure has to be same. Thus, by finding the pressure at B, we are able to find the pressure at A. But how do we figure out the pressure at B? That's the question. Yes, we'll have to make use of the density, the known density of the liquid, then the height and acceleration due to gravity. So all of those set of information we need to make use of and figure out. So PB is equal to P naught, right? That's the weight that PB is carrying, and also the weight of your rho GH. Okay. Right? It's also the weight of rho GH. Now, PA will be equal to PB plus rho GH. Okay. Sorry, not PB, my bad. What am I writing? P naught plus rho GH. Why? As PB. Oh, actually, we have written the reason. Points as points A and B are at the same height. And that's your formula. Okay, so this is called as absolute pressure. And this is your gauge pressure. That's your gauge pressure. Okay, guys. So for example, the pressure that you measure in your bicycle tires, right? It's the gauge pressure. Okay, so it can be positive, negative. It depends on basically Well, the difference. So gauge pressure can be positive, negative, and of course 0. If the pressure is same outside inside, then the gauge pressure will be 0. So positive indicates the pressure inside the container is more than that atmosphere. So if you open the tap, the air will come out, right? So this is wherein air is going to come out, like in the plane. Okay, so if you have seen the videos, of course not the movie videos, that is movie scenes wherein if a plane window opens up by chance or whatever, if someone opens, I'm not getting the plane. Yeah, if something opens up over here, if they open the door and the gush of air goes out and stuff like that, so the pressure is more, while the negative things will go in. So how can I show you guys this? Where do we observe this actually? Okay, I'm not able to recall. Okay, so yeah, that's that. So this is your open tube manometer. Very simple thing, but using the concepts that we have learned. And all these are doable. We can build this. So actually, sorry, I didn't mention about rho. Rho is the density that we know of.